Hi everyone, Assalamualaikum. In this video, we are going to discuss example 2 under integration by parts. Evaluate integration of ln x minus 3 dx. Okay, we look at the solution. Okay, when we integrate ln x minus 3 dx, x minus 3 is inside ln function, means ln x minus 3 come together and it is single function. Okay, when we are given a single function and we need to evaluate using integration by parts, the single function is confirmed to be u and dx will become dv. Right? We recall back, not that dx always include in dv. Okay, so from here our dx equals to dv since u equals to ln x minus 3. Alright? Alright, so from here we can write integration of ln x minus 3 dx equals to integration of u dv. Okay? Ln x minus 3 equals to u from here. And then we can write u equals to ln x minus 3. Okay? Dx equals to dv. So we can write dv equals to dx. Okay? From u, we need to find du to substitute in this formula. And from dv, we need to find v to substitute into this formula. And from u, to find du, we need to differentiate. When we differentiate u with respect to x, we have du over dx, which is equals to 1 over x minus 3. Okay? And over dx from left-hand side here, we need to move to right-hand side. So we have multiplication of dx here. Right? Because we need to write du as a subject to substitute into this formula. Right? And then from dv, we need to find v. So from dv to find v, we need to integrate. Okay? When we integrate, we have v equals to x. Okay? Alright, when we integrate dv, means we integrate 1 dv. Okay? And when we integrate 1 with respect to v, the answer equals to v plus c. Okay? When we integrate dx, means we integrate 1 dx. So the answer equals to x plus c. Okay? No need to write plus c. Right? Or for quick method, we can close d for both sides. When we close d for both sides, we can see v equals to x. Right? And after that, we need to multiply u and v from this formula. And we multiply v and du from this formula. Right? Right, after that, we can write integration of u dv equals to uv minus integration of v du using integration by parts formula. Okay? And from the given question, we are given logarithmic function, which is non-repeatable function. Okay? We already discussed non-repeatable and repeatable function in the previous video. Okay? From this question, we doesn't has repeatable function. Okay, repeatable function means exponential function or trigonometric function. So if from this question, when we use integration by part, if there is no trigonometric function or exponential function, we can't use tabular integral. Okay, we will discuss the example using tabular integral in example 5 later. Okay. Alright, so we back to this formula. Okay. From integration by part formula, integration of u dv equals to uv minus integration of v du. Then we can replace one by one. Okay. We replace u equals to ln x minus 3. We replace v equals to x. Okay. To avoid error, we need to write x in front, okay? In front ln, okay? Because when we write x here, some student will intend to multiply by bracket x minus 3, okay? And actually, we cannot multiply x and bracket x minus 3 because bracket x minus 3 is inside ln function, okay? So, to avoid error, we can write x in front, right? So, we have u equals to x, v equals to x from here, and u equals to ln x minus 3 from here. And then we have minus sign, and then we have integration sign from this formula. And then we replace v equals to x, and we replace du equals to 1 over x minus 3 dx, right? And after that, from here, we cannot simplify x and x in denominator here because x here, we have x minus 3. Okay, we have subtraction function here. Okay, or subtraction operation here. Okay, so we cannot simplify. So, we have x ln x minus 3 minus integration of x over x minus 3. And we also cannot move out variable from integration sign. Okay, we only can move out constant from integration sign. So now we have x over x minus 3 dx. Right, how to integrate rational function x over x minus 3 dx? Okay, right, from here, from numerator, we have degree 1. And from denominator, we also have degree 1. Okay, remember when we discussed in the previous video. Okay, this is improper fraction. The degree of the top is greater or equal to the degree of the bottom. Okay, so in this case, the degree of the top is equal to the degree of the bottom. So this is also called improper fraction. So what should we do when we have improper fraction? Okay, if we need to integrate. Okay, in this case, we need to use long division. Okay, alright. So from here, by doing long division, we have x over x minus 3 equals to, we put x minus 3, the denominator, outside division symbol. And then numerator, we put inside division symbol. Okay, we can write x plus 0 for any missing term to avoid error. Okay, and then from here, x times 1 equals to x, and then minus 3 times 1 equals to minus 3, and then to avoid error, we must put bracket, and then minus sign outside here. So now, x minus x equals to 0, no need to write. 0 minus minus 3 equals to positive 3. Okay, now the degree of the last row less than the degree of divisor. So now this is called remainder, this is called quotient, and this is our divisor. Okay, and after we use long division, we need to write x over x minus 3 equals to quotient plus remainder over divisor. Okay, and we have x over x minus 3 equals to, our quotient is 1, and then plus our remainder equals to 3, and then over divisor. Okay, alright, when we recall back in the previous video in topic integration using partial fraction, if we need to use long division method, so after that we need to express remainder over divisor into the sum of partial fraction. But in this case, we not use partial fraction because we only have one factor here. Okay, so we cannot factorize again. Okay, so we only have single factor here. Okay, so from here, we can write x ln x minus 3 minus, we still have integration symbol because we still not integrate, and then x over x minus 3, we replace by 1 plus 3 over x minus 3 using long division method, right? And from here, we can separating the integrals, okay? So we have x ln x minus 3 minus, we separate this, so we have integration of 1 dx plus, we can move out constant 3 from integration sign, and then 1 over x minus 3 dx, okay? And after that, we integrate in bracket 1 by 1, okay? We no need to integrate x ln x minus 3 because there is no integration sign, okay? So we still have x ln x minus 3 minus, when we integrate 1 dx, so we have x, and then plus, we still have constant 3 in front, and when we integrate 1 over x minus 3 dx, the answer equals to ln x minus 3 plus c. Okay, after we finish all the integration, we can put plus c at the back. Okay, right. So we integrate 1 dx, the answer equals to x. We still have constant 3, and when we integrate 1 over x minus 3 dx, the answer equals to ln modulus x plus x minus 3. Okay, right. How to integrate this? Okay, we have 3 methods to integrate 1 over x minus 3 dx. Okay, alright. For shortcut method, okay, number 1, when the numerator is a derivative of the denominator, so therefore the answer equals to ln denominator plus c. Right. So from here, the numerator is a derivative of denominator. So the answer equals to ln denominator. Okay, this is a quick method. Or we can use formula integration of ax plus b, which is linear, this is linear function, to the power of negative 1. Okay, we can write integration of 1 over ax plus b, bracket to the power of positive 1. No need to write bracket to the power of positive 1, dx. Okay, so from here, okay, and then we have 1 over a. In this case, our a equals to 1. So we have 1 over 1 ln ax plus b means x minus 3 plus c. Right? Or you can use integration using u substitution. And we choose u equals to x minus 3. Okay? You can try this method by yourself. Alright? So the answer when we integrate 1 over x minus 3 dx equals to ln modulus x minus 3. Right? And after that, we need to expand, okay, to eliminate bracket symbol. Okay? So we have x ln x minus 3 and then minus and positive here. So we have minus x, minus and positive. We have minus 3 ln modulus x minus 3 plus c. Okay, this is the final answer when we integrate this function. Okay, to integrate ln x minus 3 dx, we need to integrate using integration by parts. Okay, and when we integrate using by part, we have 2 methods, either using formula or using tabular integral. But we only can use tabular integral if the given function from the question in the form of exponential function or trigonometric function. Okay? So this is the final answer. In this case, we only can use integration by parts formula. Alright? Okay, so this is the complete solution when we integrate ln x minus 3 dx using integration by parts. Okay, inside by part, we still have integration symbol, and in this case, inside integration symbol, we need to integrate using long division method. But we no need to use partial fraction because from divisor here or denominator here, we only have one factor. Okay, so we cannot split to sum of partial fraction. Okay, so we just use long division only inside sub integration here. Okay, integration by part means that in integration we still have integration symbol. Okay, got it? Coming up next, formula integration by part, integration of u dv equals to uv minus integration of v du. We will discuss example 3, integration of 2x inverse tangent x dx. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.